This is the Next Horizon Applied AI Research for Security. We've got Alexander Stojanovic, VP of Microsoft Security, Next AI. Let's hear it for him.
Ladies and gentlemen, good afternoon. I'm glad to spend a couple of minutes with you today talking about what we do in Next AI. I'm Alexander Stojanovic. I run Next AI, and when I try to explain to potential recruits what we do, depending upon their inclination, I either tell them it's Stark Industries or Q Section, depending upon whether they like Marvel or James Bond more. Our goal fundamentally is to explore the next horizon of where AI and security are going. We're motivated by this idea that I flashed on the screen that the future of AI isn't in answers, the sort of first generation of generative intelligence, the conversational, interactive, I have a question, you answer it. It's more about how we can really prime the pump from real-time insights at very large scale through understanding and discovery, and then get to extremely impactful actions that can be autonomic. In other words, continuous and automatic, but more importantly than that, that they can be trustworthy, that they can be observed, they can be governed, they can be audited. And that frames a lot of what we do within our lab. So the single word that I use to describe Next is innovation. We seek to understand how to innovate across both how we build very large-scale AI security systems, how we can basically bring to the forefront adaptive intelligence and learning so that our systems, in some sense, can actually build themselves, they can extend themselves, they can refine themselves in time. And we think that that will unlock the sort of next tier in autonomic intelligence. We're also always experimenting with new AI-powered experiences for users as well as for computational agents. In other words, how can we make our platforms and tools the most adaptive and most suitable for human users, but also the just plethora and kind of Cambrian explosion of security agents that are going to be built on the Microsoft platform by Microsoft, as well as our extremely wide and deep ecosystem of partners. When I look back what the lab has done in the last last year, I should say, we've really had an opportunity to deliver our research, our applied research, through a number of products. AI Foundry, Sentinel Platform, and very specifically, our sister team, Security Copilot. And that has ranged across the wide gamut of features and capabilities. The semantic AI search features of the Sentinel Data Lake, powered by MCP, is work that emerged out of Next AI Lab. Our work on AI observability and continuous tuning and distillation and model selection at runtime and at deployment is work that Next AI pioneered. We've also spent a huge amount of time in developing intelligent agentic frameworks. So to help security programmers, SOC teams, not only develop agents with low-code environments, but to help tune them both at design time and runtime so that they're more effective, they're more efficient, they're more explainable, and they're simply easier to run at mass scale. We've also done things like provide natural language understanding interfaces to Sentinel and Security Data Platform. And we've done some state-of-the-art work in multi-turn agentic prompt optimization. So how do you take someone's hand-built, curated agent, run it through an AI system, and produce something that runs faster, is more effective, and is often much cheaper to run in both time and cost. That's just a bit of the past, the recent past. Now I want to actually talk a little bit about what's guiding Next AI in the next wave of initiatives that we're developing. And we see a number of forces that are emerging and which guide us. Remember, Next is about figuring out the next 2-3 steps of where the market is going and building products that are going to converge there. One of the most important things that we've actually seen is the rise of vibe hacking. So everyone knows, vibe coding, and there are a lot of interesting tools there. Unfortunately, the paradigms of vibe coding work very well for cyber criminals, whether they're nation-state actors or criminal gangs. And so the term that we basically have used is vibe hacking, the use of generative AI technologies to do extraordinarily sophisticated, subtle attacks, whether they're attacking containers, whether they're attacking web applications, low level in the network stack. I'm sure many of you have seen in recent days a report published by Anthropic on the first deep use of detected use of vibe hacking, turned out likely by a nation-state actor to get into a system. They used every tool that we would typically use to build a safety agent, an AI safety agent, to attack. Secondly, we're very motivated by what we see as the sort of hyperscale of federating data and security artifacts in all their shapes and sizes, and to be able to interact with them and process them in real time. So how can you federate and search over an extraordinarily heterogeneous set of security artifacts from application logs to documents, threat intelligence documents, to synthesize and operate at real-time scale? That's an extraordinary challenge in at least 2 dimensions. We're also interested by building AI systems that can help humans and agents do better discovery and remediation at scale without human attendance. In other words, autonomic threat detection, classification, and repair. And finally, and this is an interesting dimension of the work that we do in Next, is the sort of, and I'm going to use the E word, econometrics, how do we change fundamentally the cost equation for building and scaling security domain-specific agents? In other words, how can we take today what is still a somewhat specialized skill set to build an agent, to prompt it, to deploy it, and whatnot, and how can we take that cost ideally to 0? What does that actually unlock in terms of the potential to build continuously powerful and always ready to go systems? That's the 4th sort of pillar of our investigation. So if you look at the first topic I mentioned, vibe hacking, we know that there's been an explosion of enterprise web app development over the last decade or 2. Unfortunately, our research and the research of other labs has also shown that there's been an extraordinary increase in sort of AI attacks. And in many cases, for web applications, they can penetrate existing firewalls and what used to be state-of-the-art secure systems with an extraordinarily high rate of success, 96% in many cases. So our work has been, how do we build vibe hacking deterrence technology? In other words, how can we use the attacks of generative AI security agents or red agents to train state-of-the-art defensive models? State-of-the-art defensive models that can be deployed continuously, that learn from these very subtle generative AI attacks and provide truly state-of-the-art security and defense for these ultimately like millions and billions of web applications. What we've been able to do is build such systems with 99% detection accuracy, and that's done through what we call adversarial learning. We use attackers to build better defenders, and we do that continuously so that we learn from these attacks and they can be very sophisticated, and we always find ways to deploy a better defensive shield, a so-called blue agent or blue model. One of the sort of what I like to call secret sauces of what we've done is partnering with with great partners in the industry. And I'm really thrilled about the work that we've been doing with NVIDIA in this sort of real-time vibe hacking immunity scenario. Working with NVIDIA, we've been able to achieve wireline speed of these detections, which if you think about how complex these systems can be to run an AI-based defensive system, to be able to run in 1 to 5 milliseconds with GPU-accelerated kernels is extraordinary. So we've published a short blog on this, and I'm pleased that we will actually be doing a joint presentation with the NVIDIA team this Thursday at 10:30. So please do join us there to learn a little bit more on what we've done. But we've been able to achieve a 160x latency improvement over standard GPU-based techniques. Again, it's a state-of-the-art processing speed, real-time achievement, but maintaining an extraordinarily high accuracy or precision. And we have to kind of achieve both, while also dampening down on false positives. A large part of what we also do is to push an idea that I've often called concierge intelligence. How can we make AI systems that feel a lot more anticipatory to our needs rather than waiting for us to ask them to do something? So that requires a lot of engineering in the data discovery area. I mentioned federated search and semantic understanding. It requires having LLMs that can reason over and have been tuned to reason over security data. And importantly, it involves creating what we call on-demand agents. I mentioned that earlier, that are actually presented to users as a one-click action. Like, we can detect the intent of people that are using our systems for AI search on top of our Sentinel platform. And rather than just giving them a set of links to interesting related data or even showing interesting recommended additional queries that the system recommends, we can say, here are a combination of bespoke engineered agents that can do additional tasks like looking for threats and remediating them, or generate those on the fly based upon the intents, the context, and the kind of continuous background learning that we're doing with our autonomic agents in our system. So we can, in some sense, anticipate the needs of people using our system. So this is a fantastic combination of AI search, federation of knowledge, agentic kind of autonomic intelligence, and this sort of anticipatory intelligence that can really make the fidelity and the approachability of Microsoft-based AI systems so much better and, frankly, so differentiated from our competition. We also spend a lot of time in, I'll call it the bowels of LLM optimization and tuning. We've built state-of-the-art security environments for the training, evaluation, and observation of models. Working with teams like AI Foundry and to produce AI Foundry observability, we've created effectively an observation substrate that allows us not only to do offline evaluation of model performance and agentic performance, but to do it at real time using techniques which we refer to as LLM as judge. So we use sophisticated LLMs that we've engineered to evaluate how agents and other LLMs operate. So in many respects, this is the first observation platform for the AI age. And it's available today through AI Foundry observability. We're really excited about this work and what it actually enables in terms of monitoring, continuous optimization, model selection, and just in general, the kind of concierge intelligence that we can turn on to suggest things to SOC operators, CISOs, and others on how they can better secure their systems, run them more effectively, and run them more economically efficiently. I've mentioned dynamic agents because we see these as a convergence of a lot of the technologies that we've been developing in the past year and that we are currently developing and delivering. How can we deliver the kinds of agents at the point of application when a discovery of a threat has been made. And if it doesn't exist, how can we inference over the set of tools, data, context that's going to be required to, let's say, do a security investigation without necessarily having to have a human being engineer that agent, to engineer that workflow, to engineer that solution. This is the sort of strategic horizon point of our investigations, and we're really excited to be talking about it more in the near future. So our key research vectors really amount to vibe hacking, this notion of real-time processing at scale, the leverage of discovery and remediation, but then also within an economic framework that people can dial in the efficiencies and the effectiveness that they want, but that allow for a more declarative view of management and utilization of Microsoft security products. We love to engage with research institutions, customers, partners, and I've dropped in a link to an email that you can actually reach out to us on. We love to hear from people, and we certainly encourage you to reach out. Thank you very much. I really appreciate your time. Have a great rest of your afternoon.